Chapter 11, Databases. What are the learning objectives? Show understanding of the limitations of using a file-based approach for the storage and retrieval of data. This file-based approach is before the DBMS came, before the database management system came, file-based. With just one text file, all the data saved in one text file. Or you can even think of a manual system where the cardboard files are there, paper. So what are the limitations of that system? Then describe the features of a relational database which address the limitations of a file-based approach. Again, comparing with the relational database. They show understanding of and use the terminology associated with a relational database model. So there is a certain terminology. You will be learning that, some terms, the jargon used in this database. Then use an entity relationship, ER, E for entity and relationship, R for relationship. ER diagram to document the database design. When you design a database, you have to design, just like designing a program system. You have to design how the database, how the tables and the records are going to be. So this ER relationship, the diagram will help in doing that. Show understanding of the normalization process. There's a process called normalization. So that is organizing the tables. Explain why a given set of database tables are or are not in 3NF. Once you normalize, we talk about normalization. That is, when you do the first stage, will take you to first normal form or 1NF. That is from the normal text base file. You have one text file, you have all the data in one file. That will, with the normalization, the first stage will take you into two files, two tables. Like that, there is 2NF, there is 3NF, and you will learn how to tell whether these database tables are in 1NF, 2NF, or 3NF. Or if they're not in 3NF, that's the final stage. If it is not, then why? Produce a normalized database design for a description of a database, a given set of data, or a given set of tables. So now, how to produce a normalized database design. Show understanding of the features provided by a database management system. That means the abbreviation is DBMS, that address the issues of a file-based approach. So how is this DBMS going to issue the problems that we saw in the file-based approach? Show understanding of how software tools found within a DBMS are used in practice. There are certain software tools in a DBMS, like creating forms, reports, and things like that. Some facilities, software tools. Show understanding that DBMS carries out all creation or modification of the database structure using its data definition language. So there are two, actually. One is DDL, the other one is DML. DDL is the data definition language, which handles the structure of the database. Show understanding that the DBMS carries out all queries and maintenance of data using its DML. So the data, the actual data, maintenance of the actual data, either add, edit, or delete, is done by DML, data manipulation language. Show understanding that the industry standard for both DDL and DML is structured query language. So for both The language used is structured query language, SQL or SQL. Some people say SQL, SQL. Understand given SQL, DDL commands and be able to write simple SQL DDL commands using a subset of commands. How to write those commands in order to manipulate the data or how to maintain the structure. Write an SQL script to query or modify. Query means to retrieve data. How to get selectively, how to get the data out or modify data. Change, add, delete. That is using DML, which are stored in at most 2 database tables. Then the first part is limitations of a file-based approach. First one is data integrity. Problems in a single file. So if you have a single file, consider computerizing band bookings for a theatrical agency. So can you picture now a theatrical agency, theater agency and band booking. These are for performances. Text files are to be used. One of these text files is to store data about individual band members. Each line of the file is to contain the following data for one band member. What are the details? The name, contact details, bank details, band name, band agent name, or band agent contact details. Right? See, about one band member. So each band member, we have all these data. Let's have a look at that. So I have put this name and band name in red because that's the data that we are going to have. Name appears as F name and L name. That's the first name and last name and the band name. What are the details we have? The first record, this is like a record. As if 1, 2, 3, 4, 5, 6, 7, 8. There are 8 records and 3 fields. Zingwei Jia, band name Computer Kids. So Mahesh, Ravuru, ITV. Likewise, it goes on. So what is the problem? What is the problem? The problems are these. Absence of data validation. That is, data validation is provided or facilitated by the DBMS. Whereas in the file, the flat file scenario, it is not present. That is why this has resulted. What? Band name being blank. This is like a notepad, see? Notepad text file. There is no way of preventing of the user leaving this blank. There is no way of telling the user, enter this. Otherwise, you can't leave this field and go to the next. There is no validation. And here Graham Vandana and Vandana Graham, same person, but the names entered incorrectly. And here one person playing for 2 bands. That is also not correct. So these are operator mistakes, but no way of preventing them. The database approach can prevent such problems or at least minimize the chances of them happening. Database approach can minimize that kind of mistake happening. Then the second one. So the first one is what? Data integrity. Data integrity. The first one. How consistent is the data? That's integrity. And second one is data privacy or privacy. No control of access to part of a file. So you can't have a control and say that this part is only for these people, the other set of users, this section. You can't. So staff in the recruitment section would be able to access the banking details of band members. That is the problem with this. There's no privacy because everyone can have a look at these bank details, where it is relevant only to the finance department. Only the finance department needs this detail, but all others can see this. In the flat file scenario, the DBMS, this problem is not there. Data privacy would be properly handled by a database system. Then third one is data redundancy and possible inconsistency in multiple files. To overcome the privacy issue, the different files for different departments. This data redundancy means the duplicated, extra. The data is being repeated in several places. How does that happen? Because of this, now if everything was in the, now look at this, supposing it is easier to understand the physical, the manual system. You have 3 files. If you have one file in the office where you have all these data, let's take about a student. It's easier for you to understand. A student, the admission, the data, the name, address, phone number, all those things are there, plus the fees, term fees, the fees paid, fees in arrears, and then the class details, the attendance, everything in one file. So in order to avoid the privacy issue, what the school would do is take the administrative part into one file, physical file, and give it to the office. And take the term fees and the arrears and those things, create another physical file, separate, and give it to the finance department or the accounts department of the school. And another one for the teachers with the attendance details and all that, the dates and all. So when you do that, what happens? One of the primary aims of the database approach is the elimination of data redundancy. So there are problems. It's not mentioned here, but there are some problems when you have 3 files, 3 separate files, where the data is duplicated. That is what you call redundancy. Why? What is the data that is duplicated? All 3 files will have the student admission number, name, phone number, all those details. Of course, admission number is necessary. There has to be one primary key or some way of connecting it, who this student is, to connect to the name and all that. The admission number should be there. But the name is everywhere, all 3 files, the phone number everywhere, etc., etc. Now look at this scenario. A student or the parents of the student, they change the SIM or the phone number. And you are supposed to advise the school about it. So the parents send a letter to the administrator of the school saying that the new phone number is such and such. Then what happens? The administrator will change it in a file and advise the other 2 also. Who are the other 2? One is in the finance, the other one is in the classroom. The teacher has it, class teacher. So phone number is changed in the admission number. Then this message goes to the finance, they will change, and the class teacher will change. If everything is done properly, okay, there is no problem, absolutely no problem. But only thing is, as it is, you can see before the problem comes, before I highlight the problem, as it is, you can see that there is extra work. Just one telephone number, you have to change in 3 places. Whereas the DBMS, it's not there because we have overcome the problem of state of redundancy. No duplicated data, only in one place. Whatever the data, change only in one place, and that will reflect in the others. So that is one issue, extra work. Then, in addition, think of this. administrator changes and sends it to the finance and the class teacher. The finance people, they change it. Class teacher forgets or, right? Doesn't. So there is inconsistency. Also, maybe the finance department, they will change it incorrectly. Some error in changing. The new telephone number is not written down properly. It's wrong. There's a mistake. So there are inconsistencies. So the data integrity is also again under threat. Okay. So one of the primary aims of the database approach is the elimination of data redundancy, where there's only just one change, one place. So data dependency concerns. Just to recap, what did we do now? First one is data integrity. Data integrity. Second, data privacy. Third, data redundancy. Now the fourth is the dependency. Data dependency concern. What is the data dependency? When a programmer creates a program for a department, the programmer has to know how the data is organized in these files. For example, that the fourth item on a line in the file is a band name. So let's see how the programmer has to have this changing of this data and all that in the program. If there is a change in the file, the program also has to be changed. Look at this file, which has the data that we saw earlier under F name. Here's Yang, Y, all those my data. Then L name. Then, sorry, this without this, let's see. Yeah, we have the band names here. That one without a band name for Dylan Stoddard, without like this. So those days, even I have done when I started learning programming, like GW Basic. That time, the flat file system was there, so we had to define now this. If this is the file, we are in the program. We are giving the instruction either to write or read or save or retrieve. You have to say F name in the program, right? F name equals 1 to 8. First, of course, the file name. File name has to be defined in the program. I didn't do that part here. File name 1 to 8. That means 1, 2, 3, 4, 5, 6, 7, 8. This number of characters here. You have to specify. 1 to 8 is the first name. Then comes L name, last name. From the next character, 9. 1 to 8 is the first name. 9 begins the L name. So 9 to 16. And then the band name, band 17 to 30 from the next character to 3. But I have given spaces here, but generally you don't get, you have very close to this. You don't get spaces like this. I gave it for clarity. Then it's clear to understand. It's easy. So now thereafter in the program, I use this F name. If I want to input or if I want to display or take a printout, then when I want to say print this line, I will say print F name, comma, L name, comma, band. Then this line will be printed. Okay, so that is all right to a certain extent. What is the limitation? Suppose you want to include the phone number here. Okay, phone number. So included and written to the file like this. We change the file. Then what happens to this? Now, when the programmer, then the program looks for phone number or band, when the program will have this band is 17 to 30. So band will be taken as 17, 18, 19, 30 like that. What is coming? phone number. Phone number is coming. Why? Earlier 17 to 30 was correctly the band name. But now 17 to, if you don't change it, it's 30. If this 17 to 30 is not changed for the phone number, this phone will have the band name. And this one, the band will have 31 to something. So in order to correct it, we have to, instead of band here, we have to have the phone there with those numbers. If it is exactly the same number, yes. Otherwise, this was 17 to 30. This might be 17 to 35 or less, 17 to 25 or whatever, depending on the phone number here, numbers. And then we have to adjust. Earlier band was 17 to 30, now 31 to something. So those are the problems. See, this is an example of data dependency. The data in the file depends on the way it is written. The program you have to define. If there is any change, the data will need to be entered into new files. This will require the existing files to be rewritten. So text files you have to rewrite. You can't just enter programmatically. Remember, we are not just taking this. Where is that? Yeah, this one. The text file. It is not a case of just take this and then go on typing the names and everything. It's done programmatically. Reading is also done programmatically by a program. Writing is also done. Or if another record is to be written here, the writing program or saving program or storing program, we'll have to write it here under program instructions. In turn, this will require the program to be rewritten so that the new files are read correctly. The programs also have to be rewritten, like how I showed here. Now there's a change in the program. So rewritten means that earlier there was no phone at all, and the band was 17 to 30, but 17 to 30 now it's phone. Or to make it more appropriate or more easy for you to understand, I'll make it 25. Band was 17 to 30. Then this is telephone number is less than that. So starting 17 and finishing at 25 and going on 26 to maybe 35. Like that. That is writing the program or amending the program. So that is also the dependency concern is that data, the programmer has to change the program also. Whereas, so what about the DBMS? DBMS, you don't have to worry. You can insert fields, you can delete fields, and the program will run the same way as it used to run earlier. There's no need to change it. Now we come to another section, the relational database. So this is actually what we are interested in, not the earlier one. Earlier one was the old system, and we have to learn the background. What are the advantages of DBMS? If you don't know the old system, you can't write. Now you know the old system. These are the problems and the advantages of the DBMS. Now you know. So relational database, a collection of relational tables. Database is a collection of related tables or relational tables. The design for a database for the theatrical agency might contain the following table definition. What? This is the way. When a table is defined, now you will learn this is the standard way. You write the name of the file or the table and the fields within the brackets, within round brackets, the fields which are there. Like, for example, in the member file, you will have member ID, member given name, member family name, band name, etc. Then there's another table called band, which will have the band name, agent ID. There's an agent for usually the bands. They are just practicing all the time and improving themselves. They are not. They don't have time to go looking for bookings for performances. For that, there's an agent who will do the publicity and get businesses their performances. So that the band will have the band name as well as the agent ID. So look at this now. Now this member given name, member ID is this here, member given name, member family name, band name. So these are the fields. We know that these are the fields in this table. Why is this underlined? Is there an error? No, this is underlined. That's a standard way of saying that this is the primary key of this table. Primary key of this table. So the member ID is the primary key of member. Band name is the primary key of band. So these are the logical view of the two tables is this logical view. It's not this. Physically you don't have like this, but logically you can imagine like it's like this. So the member ID will be this, the member given name, member family name, that's a surname, band name, etc. And the band name, and the agent ID. What is a relation? We have to know these terms. Relation. The special type of table which is used in a relational database. So we know what a relational database is now. It's a collection of relational tables. So in that, a relation is a special type of table. Not the normal, just a table, a special table. It's called relation. Attribute is a column in a relation that contains values. So if this is a table, is a column. Another term is attribute, column. Another name is field. So you have enough names to describe this. Attribute, field, or column. Then a tuple. Tuple, a row in a relation, storing data for one instance of the relation. So this is the relation, the table. Tuple also is called a record. Right? Tuple, record, what's another term? A row. A row. Tuple is a row. Attribute is a column. Right? So there are three names for the tuple also. Tuple, record, or row. So record is a horizontal, this way. And the attribute or the field is vertical, column. Then let's talk about the primary key. Primary key. Most important feature, either single attribute or a combination. Single attribute. Can you picture it on your own? Can you evaluate it? Picture it. What is this? Can you figure it out? A single attribute. What are the attributes? Now you know the term attributes, no? These are the attributes. Another term is field. Another term is column. So if you take this, either a single attribute, that is one of them, or a combination. There may be two, the first name, last name, but they have to be unique. That is a primary key. Primary key can be either one field, in simple terms, one field, or two fields combined, but it has to be unique. One of the candidate where you have to say a row in a relation storing data for one instance of the relation. So one instance means this relation means one item, like member ID 5 will be regarding this person, everything on this record. The family given name, member family name. member given name, member family name, band name, all those things regarding this person. So this 0005 member ID will not appear or occur again anywhere else in this table. In this table, on this primary key column, this will appear only once. That is the meaning of uniqueness of this. Then let's see about other keys. One of the candidate keys will be selected as a primary key. So candidate keys means those who are like willing to either volunteer or like the election, for the election, the candidates are there, or for the exam, there are candidates. For an interview, there are candidates. Only one will be selected. So here, like suitable, what is suitable? First name can be taken, but yeah, second name also, last name can be taken. Band, but then you find that band name, of course, is not suitable because band name you can have any number. But if you just take this member given name, there can be more than one person by the same name. So if you take the other one, consider this one, that also, the surname also, there can be more than one. So they are not 100% suitable. They are candidate keys, but they are not 100% suitable. Then what do you do? If no candidate keys, so now in this case, we don't have, forget about this member ID. Only these data we have. If no candidate keys, a primary key has to be created. Example, member ID in member table. So when the candidate comes, he doesn't bring a member ID, no, he brings his name, surname, band name, the address, phone number, those things are there. But this is created at that time so that this will be unique. This will not be unique. There can be more than one person by this name, by that name. So nothing will be unique except for this. That is why you make one. Primary key has to be created. In database design, primary key is underlined. We saw it earlier, underlined. Let's have a look again. Here it is. Member table, the member ID is underlined. Band name is underlined. So they are the primary keys. Easy. The primary key ensures integrity within the table. So there is no duplication. The 0005 will not appear anywhere else in this table. So there is no duplication. So integrity, no problem. Then foreign key enables tables to be interrelated. What is that now? Supposing these two tables, if you take, let's take a sample. Now you have member ID, these 4 IDs, unique, F name, L name, band name, various other data. Then band, you have the band ID, and the booking, you have the booking ID. So this is the primary key of member ID, and this is the primary key of band ID. Now the bookings of the theatrical agency will have bookings now. Booking ID, there's a booking ID, unique one, 820. Theater is Rio, band is AB. In case you want to find out who the what is the band name? What is the band name? Then also, yeah, if you want, what is the first name? First name of this member ID. Then what do you have to do? You have to access from this one. You are starting from here. You access the band ID. See, AB it's matching. Same. It has to be same size. Huh? The field names have to be same size and the same type. If it is text or string, it has to be both the same. Then you access this. And if you want, from here, you can access the band member ID. Member ID for this band. In case you want to have the first name or the last name, then you access the member table with member ID, matching with this member ID and member ID. So you access 1, 2, 3, 4, then you can get these details. So for doing that, to do that, these are called the foreign keys. The mem ID is a foreign key for this. This is a foreign key for that. Okay. That is what this one says. Foreign key enables tables to be interrelated. So you saw the relationship now. From here you can go into this. From there you can go to that. That's a relationship. Again, now primary key, an attribute or a combination of attributes for which there is a value in each tuple and that value is unique. Candidate key, a key that could be chosen as the primary key. There are many keys, candidate keys. From there, only one primary key will be chosen, which is unique. One main feature is uniqueness. Secondary key, a candidate key that has not been chosen as the primary key. So there were several, if there were several candidate keys and one was chosen, others become secondary keys. A candidate key that has not been chosen as the primary key. Then comes a foreign key, an attribute in one table that refers to the primary key in another table. We saw that also in the example. So here it is given use of foreign key. So the foreign key here is the band name to access this band table band name. That is the way the foreign key works. Then referential integrity. Referential integrity, what is that? The use of a foreign key to ensure that a value can only be entered in one table when the same value already exists in the reference table. That is a very useful feature. Yeah. For example, if you want to enter a new member, member, right, for a particular band, say IT Viz. And in the program, in the entry program, entry screen, you enter the name, all those things, and you put the band name as ITWIZ, just one is it, spelling mistake. Or it will put my band, and then it will say it's wrong and say it doesn't exist. ITWIZ doesn't exist, or my band is invalid, or something like that. Okay? The use of a foreign key to ensure that a value can only be entered in one table when the same value already exists in the reference table. So if you enter, if it is not there in the master file, this is generally called the master file. If it's not there, it will give an error message saying it's not valid or it doesn't exist or something like that. Same way, if you want to delete, suppose you want to delete this computer keys, then it will say you can't delete because there are members here, 2 members here under computer keys, and with all their details are there. So you'll have to delete those first and then command delete here, right? Ensures the band name entered in member table really exists. So those two things are there. Referential integrity. So you refer to the other table and check whether, so spelling mistakes can be detected that way. If the user makes a mistake, then there is a worked example 7.01 in the textbook. creating an entity relationship diagram for the theatrical agency. The starting point for a loop for a top-down design is a statement of the requirement. So top-down design, I think we are not done them yet. Top-down design is something like this. Make tea is a top level task is to make tea. This is an example. So if you have only this one, the instructions are there written like a cardboard here, a card, which instructions to make tea. Then only one person can handle the project or the problem or the task. Whereas if you break them into three sub-programs or sub-tasks, one is to boil water, another one to brew the tea, another one to add sugar. This is also called modular programming. You know, these functions and procedures you will learn later. Then you will relate to this. So now these three cards are there with instruction. Now three people can attend to this. Right? One will boil the water, another one will brew tea, another one add sugar. So that is there. Top, down, left, right. Left, right is not mentioned, but generally left, right is also valid. But top, down, that is the meaning of. Then this boiled water also can be detailed like this. Another three, or there are no numbers, fixed number. This is I just I happen to put three arrows and then put three tasks. So here also any number of tasks is possible. So creating an entity relationship diagram, we have to do that. How do you start? The starting point for a top-down design is a statement of the requirement. It's like a problem statement. Here it is. The agency needs a database to handle bookings for bands. Each band has a number of members. Each booking is for a venue. Each booking might be for one or more bands. That is a complete statement. From this only, we have to build up. Step one, choose the entities. So we'll entity relationship, no? What are the entities? You look for the nouns. You look for the nouns. What are the nouns? If you go through this, you will find that the nouns are agency is a noun, bookings, noun, bands, noun, members, venue, those are nouns. So step one is to choose the entities. You look for the nouns. You ignore agency because there is only one instance. So agency, there's only one agency and we are not going to write that everywhere. So only one instance and that is ignored. You choose booking, band, member, and venue. These are the yellow colored ones. And venue. For each of these, there will be more than one instance. So there will be more tables like instance. Instance is the occurrence. So you are all aware that each booking is for a gig. That's like a performance, so gig. For a gig at a venue, but you ignore this because you think that the booking entity will be sufficient to hold the required data about a gig. Then what? Step two, now after identifying the nouns and so those will be the relations. For each of these nouns, there'll be a relations or a table. Step two is to identify the relationships. This requires experience. But the aim is not to define too many. You choose the following three. Booking with venue, booking with band, band with member. You ignore the fact that there will be, for example, a relationship between member and venue, because you think that this will be handled through the other relationships that indirectly link them. You can now draw a preliminary ER diagram as follows. Look at this, the four relations just written and a line drawn to connect it. That's a preliminary thing. You have to now refine it. Decide the cardinalities of the relationships. Cardinalities like how many, 1 to 1, 1 to m, the relationship. First, we have to choose one of the following descriptions for the cardinality of each relation. 1 to 1. These are the four cardinalities. 1 to 1, written as 1 colon 1. 1 to many, 1 colon m. Many to 1, or many m to 1, m to 1. Many to many, m to m, like this. Colon is in the center. So take one by one. M, member, band. So take member and band. M this side and 1 that side. That means one member can be in a band, can join one band. And one band can have many members at least, or at least two should be there, more than one. But that depends later. There will be some more marks coming like this. So for the moment, this is one to many means like one band, many members. One member, one band. One member can play for only one band. The member can't play for two bands. It's illegal. On the other hand, one band can have many members. So M to 1, that is the notation used. Member must belong to only one band. Band must have more than one member. Okay, that is this part here. The two lines here. Member must belong to one band. Okay, it's same as that. Band must have more than one member. More than one member. So the minimum is 2, no? With one you can't. Minimum we have 2. So both band must have more than one member. That is the indication here. Here's another case, another condition where booking and the venue, the relationship. This one booking is for only one venue. So many to one here. This side, this symbol. This is the many symbol. Look at this again. Many symbol is this to indicate many. The 3 lines like this. And this side, if there's nothing, that means 1. So one booking is for only one venue. One venue can be for many bookings. This one menu can be for many bookings. That is this idea. What is the circle? Also, one venue may not have had any bookings so far. So this circle indicates that there is a venue mentioned, but no bookings so far. That is also there. Then another one, band and the booking, many to many. One band has many bookings. One booking can be for many bands. So both sides, the many symbol is there. Also new band may not have had any booking so far. So in the band table, there is a new band which so far has not got a booking, the new band. Beginners, they have just joined, but they have applied and been selected, but no booking so far. That is this circle. And the final one is member. One member belongs to the band. Sorry, members, right? Many members. Band has many members. But you go this way. You read like this. Belongs to band. Then a band is booked for booking. A booking or many bookings here. Yeah, book for many bookings. Then many bookings made at venue. One venue you can have many bookings. Then you go backwards like this. One venue is booked for many bookings. One booking is for many bands. And then one band has many members. So this is ER diagram for the theatrical agency's booking database. But you don't get so complicated ones for the exam. So far, exams only there are about 2 or 3 the most, which has come for the exam. But you have to be thorough. Then a logical entity relationship model. A logical entity relationship model. Above diagram can be defined as a conceptual model of the database, as it does not relate to any specific way of implementing a system. So that doesn't tell you how to implement a system. This model has to be converted to a logical model. If a relationship is one to many, no further refinement is needed. One to many, no need of any extra work. The relationship shows that the entity at the many end needs to have a foreign key referencing the primary key of the entity at the one end. So here is a clue here. When you draw the relationship diagram, if it is one to many, this side, the many side, must have a foreign key in order to access the other one. Then one-to-one. One-to-one relationships are rare. One-to-one relationships are rare and need not be considered. So simply, quietly forget about these one-to-one relationships. But remember the meaning. In a many-to-many relationship, a foreign key cannot be used. Right? A many-to-many relationship, a foreign key cannot be used. A foreign key attribute can only have a single value. So it cannot handle the many references required. So many-to-many you can't have because you can't have a single value there. What is the solution? Link entity. Link entity. We saw in the, also it will be in the note. Saw that. Supposing if you want. Now from this table, booking table, can we access this if you want to get the first name of this one? You can't, no? Because this has no foreign key for that. So then you have to have a link one. That is why you have linked this to the band table first. From there, you link to the member ID and get the first name, last name, everything. So this is the link. This is the way to link. Band. You can't directly access the venue from band. So what you do is have the band booking in between, a link table, link. So you access band booking from this band table. From this, through this, you access the venue, whatever that you want data about the venue, because the venue data is not available here, and you can't. There is no relationship here, band and venue. There is no corresponding primary key or whatever. So what happens here is table name. Now the band is here, band, and the primary key is band name. Band names are unique, no? So you don't need a thing called band ID. You don't have to create a primary key. The existing band name can be used as a primary key. Why? You can't have like the Eagles or I don't know. There are hundreds of bands, the Beatles, the old one. Nowadays, I don't know. You don't get two bands by the same name. So that is unique. So now you see band, the primary key is band name. There is no foreign key here. So one to many, this is the one side. And band booking here, two foreign keys. It should have two foreign keys. See, looking at this, you can say two foreign keys. And band booking, there are foreign keys here, band name and booking ID. Band name and booking ID. So band name is the primary key, band name and booking ID, because it's a combined. It's called a combined composite or combined key, primary key. From this side, you access this band with the band name. Right? Band name, access that. This side, if you want to access the venue, the booking ID. Booking ID, booking ID. With this, you can have that. And the primary key is both together, combined. This AND is like concatenating, like two strings or two variables concatenated with AND in pseudocode. So band name and booking ID is a primary key. Right? And the venue here, venue name, primary key. There is no foreign key in that also, because that's one to many relationship, the one side you don't get. Normalization, now very important section. Normalization. This is straight away worked example 11.02. Booking data sheet, the theatrical company might choose manually. This could be the sheet that they are using. There's a booking data number, booking data sheet. The number is there. The venue, where is the venue? Cambridge International, and the address. The booking date is there. And the bands booked, 3 bands, number of band members, headlining. So these are 2 sets of data. One is non-repeating, just once. This number is only once. But here bands booked are repeating. So look at this. Booking ID, venue name. Booking ID is this. So we are giving a field name, all booking ID for this. Venue name, Cambridge International Theatre. Venue address 1, campsite. Venue address 2, CA1. Date, this is the date. And thereafter, we are having in double brackets here. Another, within brackets, you have another set called band name. That is this. Band name, number of members, and headline. Repeating group. This is called the repeating group. There's more than one line here. Repeating group, the attributes cannot sensibly be put into one relational table. Right? Repeating group, the attributes cannot sensibly put into one relational table. So there is an unnormalized table. Unnormalized before normalizing. This is what we are going to learn, how you normalize. This is the normal, the text-based file. The booking IDs appear in thrice. Now this, can you see the, what do you call this? Data redundancy. One, the ID is appearing thrice. Venue name appearing thrice. All these appearing thrice. Only here, they are different. There is now data redundancy here with the duplication of the booking ID, venue data, and the date. So the first step is to convert it to one NF. conversion to first normal form. Two groups of tables. One is the non-repeating group attributes. The other one is repeating group attributes. So you saw identify a primary key for each table. You saw the non-repeating groups is the booking ID. Booking ID, venue name address 2 and date. Again, we'll have a look. These ones. Booking ID, the venue name, venue address, and the date. They are not repeating. The others only are repeating. So the repeating one, non-repeating booking ID. This booking is a name that we have given to the table outside the brackets, and within brackets are the field names. And what is this underlined one? That's a primary key. Booking ID is the primary key, and this is the way to show that it's the primary key underlined. Yeah, booking ID, that's underlined. Then the repeating group, band booking. So we give a name to the table, band booking, and within brackets, band name is the primary key. Not only that, this also booking ID along with booking ID. That's a compound. That's called a compound primary key. The band name plus booking ID, and the booking ID is a foreign key. Because why? Because this is used to access this. You can see the relationship. This is the same as this. So this is used to access that. The both fields together is a compound primary key. Then number of members, headlining, those things are coming. Right? Those things are coming. So this is the compound primary key and the foreign key to access the first table. For each table, now this is very important, the yellow highlighted one. For each table, the attributes are dependent on the primary key. So what is that? In order to identify whether it's 1NF, 2NF and all that, this is very important. So you must understand what this means. For each table, the attributes are dependent on the primary key. Attributes are dependent. What are attributes? These are the attributes. Primary key, depending on the primary key. Booking ID. For this booking ID, this 26 or whatever we saw earlier, for this, for this one, this is the unique one, unique number booking ID. All depends, the venue name depends on booking ID, this one. Another booking ID will have it as not Cambridge, it will have as Oxford, something. So venue name depends on this, venue address 1 and 2, date, all these things are on this booking ID, one booking. The repeating ones, band booking, band name booking, So this one, again, we'll have a look. For each table, the attributes are dependent on the primary key. So what about this? Number of members depends on the band name. Right? Headlining also depends on the band name, depending on the band, only these two. So they are dependent, fully dependent. Now we know that if that is satisfied that condition, then you know that it's in the first normal form, 1NF. And the second step is to convert to second normal form, 2NF. Is any non-key attribute, you have to read very carefully and understand this. Is a non-key attribute dependent on both parts of the compound key? Any attributes that are dependent only on one of the attributes in the compound key must be removed out into a new table. So number of members is only dependent on the band name. Number of members only dependent on the band name, not on this or both. Booking ID. The number of members doesn't depend on the booking ID. No, booking ID can be anything, today's booking, tomorrow's booking. Doesn't depend on that. But it depends on the band name. If it is computer kids, then 7 members or whatever. That is how it depends. So if it is only on one, then you have to remove that. Number of members is only dependent on band name. Any attributes that are dependent only on one of the attributes in the compound key must be moved into a new table. So what do we do? Earlier we had, what are the earlier tables we had? Band, the booking and band booking. Right? Booking and band booking. Now what? Now we have an extra one called band. Booking and band booking are still there. Only this is removed from this. The number of members taken out of this and put into band, the band name and the number of members. The characteristics of a table in 2NF is that it either has a single primary key, or it has a compound primary key with any non-key attribute dependent on both components. So it can be, it need not be both, it need not be two for a compound key, but you can say that it's one or both, but the essential part is any non-key attribute dependent on both components. What is non-key attribute? In this case, headlining. In this case, venue, these things. Except the primary key, all the others are called non-key. So the characteristics of a table in 2NF is that either has a single primary key or it has a compound primary key with any non-key attribute, dependent on both components. So in this case, headlining depends on both. Earlier what happened was band name didn't depend on the, number of members didn't depend on the band booking. This one. It depended only on this. That is why it had to be taken out and we created this. So now this is in 2NF. Non-key attributes dependent on both. Third one, the final one. Conversion to third normal form. If any non-key attribute is dependent on another non-key attribute, a new table must be defined. What do you mean by that? A non-key, this is a non-key attribute, this is a non-key attribute, this is a non-key attribute. So venue address one depends on venue name, isn't it? If it is Cambridge, then the venue address one depends on this. If it is Oxford, this venue address one will be something else, not Cam Street or whatever that was there. It will be different. So non-key value dependent on that, you have to, if any non-key attribute depends on another non-key attribute, a new table must be defined. So you have to take them also out. What is that? Venue. For the venue also, we have to take another table. So we have the band booking, and venue. In that venue, we have taken out this venue name, venue address 1 and venue address 2. Data doesn't come now because date can be different, but these two are dependent on this. So now see how that one table became 4 after normalization. So that is done. Now the database management system, DBMS. The database approach, the basic concept of the 3-level model: external level, conceptual model, and the internal level. So in the diagram, it's an ANSI given model. ANSI is American National Standard Institute. Right? That's also like the IEEE and all that. It's very well accepted and respected organization. So the ANSI 3-level architecture for the theatrical agency database is like this. First, you start with the physical storage, the hard disk. Then you go to the internal level, which is very close. The very next level is internal level. And also it's called internal schema. You have to be familiar with these terms, internal schema. Then comes the conceptual level, which is also called logical schema. So conceptual schema controlled by DBA. DBA is the database administrator, the one who controls these things. So with his help, these people, the programmers, they write programs and with different views, contract view, publicity view, finance view, recruitment view. See how the finance view. Only this program can access this. The contract view, they can't access this. And recruitment view, they can't access contract view. If you want, the user has to go to this program and look at it. So the data is available to different levels of people or different programs. The DBA gives the access rights or the different levels. So schema. What is schema? I told you have to be familiar. Schema is the details of storage. How the tables and the database is stored. So external level, individual user or programmer views. Access rights can be by DBA. We saw that earlier. Database management system, DBMS, software that controls access to data in a database. So these terms also you have to learn. Software that controls access to data in a database. That is a DBMS. DBMS is software or hardware. If somebody asks, it's software. DBMS is software. Database administrator, who is that? A person who uses the DBMS to customize the database to suit user and programmer requirements. That's a DBA. The facilities provided by a DBMS, SQL or SQL, SQL, structured query language, that's provided by DBMS. A developer interface, a programmer can have a development interface. There are software tools for that to create tables, define attributes with data types. Attributes means fields, right? With data types. What are the data types? Text or number or integer, real, date, time, those things. Facility to develop user interface. So this is the developer interface, which will allow you to have the software tools to create the tables and all those things. But now this is a facility to develop user interface. They also what the user sees on the screen. You can have nicely designed forms and all that with buttons and everything. Query processor. Query means mechanism for extracting and manipulating data from the database. That's a query, retrieving data. Then you have reports also, like printouts or on the screen, reports, extracting data and displaying. What is the developer interface? Gives access to software tools provided by DBMS for creating tables. Query processor, software tools provided by a DBMS to allow creation and execution of a query. Query itself is used to select data from a database subject to defined conditions, like selective criteria. Depending on the criteria, selection criteria, you can display. You retrieve and display. That's a query. DBMS functions likely to be used by a DBA. DBA is responsible for setting up the user and programmer views and for defining the appropriate specific access rights. There is a thing called data dictionary. Data dictionary. It's also called metadata. Details of definition of tables, attributes, etc., and how physical storage is organized. Access available only to DBA. So this is like not data. This is definitely not data like the name, the age, not those things, but how they are description of those fields. In other words, you can say data about data. The field names, field size, the data type, see? Definition of tables, attributes, etc. And how physical storage is organized. Index for a table on primary or secondary key. You can create an index also for a table on primary or secondary key. What is an index? A small secondary table used for rapid searching, which contains one attribute from the table being searched and points to the tuples in that table. Here are you can have a look when I upload this. You can have a look at these things. Also, this done by a student. The student who asked me about this. So my comments are there. Some are not possible here. So my comments are also there highlighted. And I have said can't be. But then the theory part is given here, one to many or many to one. That is what we wanted to know. Now we come to the structured query language. SQL. Then DDL for worked example 11.02. So this we have done, this is there, but then since it's not difficult to refer to the book always, I have copied and pasted it here. The worked example 11.02, normalizing data for the theatrical agency. So we did the same thing, but I have given for easy reference. I will change the layout and upload. A little bit has to be changed, but that is the just what is there in the book, in the textbook. I've just taken that for easy reference. So how this is done, everything is given, right? You can have a look at that, then you will understand. Then these are the commands. Create database, band booking. So if you want to create a database called band booking, this is the way. Create database, band booking. If you want, then create table. Create table is the next one. Band, and within brackets, you have to give this band name, all that. Alter table, band, add primary key, band name. Alter table, band booking, add foreign key, band name, preferences, band name. So you have to, how are you going to check this? You don't have to do this, but I have provided a practical for you. In your course page. Sorry. Is that I'll take, yeah. Under database. Here is SQL practical. So that's a W3 schools facility there. You can try out all these things. Here you have all the SQL intro, syntax, select distinct, all those things are there. So next, database tables. There's an explanation there. And SQL statements. You can, when you say try it yourself, you can try this select from customers. There is a These are the tables which are available. Customers, there are 91 records. So if this select asterisk is for all, select all from customers. And if you run this, you see, there are all 91 will come here. Yeah, 91 records. And if you select, okay, let's select a few fields like customer ID, customer name. How do we do that? Instead of saying asterisk, select from customers and then give the field names. Okay? So that you can practice. See how the commands are given. Okay, okay, let's try this. Create table, band, integer. Okay? I have already done that. The band is there. So band is there, band 2 is there. Let's create band 3. So you can copy this here. Create table. I'll make it band 3. And band name variable character 25 and number of members integer and brackets within brackets this set comma to separate fields. After the last field, you don't get a comma. That's all. Now, if you want another field, what do you do? Go to the next line. I'm sorry, not there. Before the bracket, put a comma. And what? Shall we say uh, just let's say number. Or agent. Let's say agent. Agent. Variable character. Say 10. And we have to close the full bracket. What we started from here, we have to close there. Now let's run it and watch this place here. So band 3 coming here, band 3, and then let's take select all, right? Select all is asterisk, no? Select all from band 3 and semicolon, remember, semicolon, run. No result because there are no members. There are, I mean, no data. We didn't feed any data. So to go through this, you can do all this. Like to add data will be insert. We'll go gradually. So this is another, you can say the alt table is to add the primary key, add foreign key and all that references, all that. The SQL consists of a sequence of commands. So each command is terminated by a semicolon, that is this semicolon. A command can occupy more than one line, that is we saw here, more than one line. There is no case sensitivity, but this we normally, the convention is to use capital letters for the commands and simple for a command. There is no case sensitivity. There has been a decision made here to use uppercase for the commands and lowercase for table names, right? Attribute names and data types. All those things, simple. When a command contains a list of items, these are separated by a comma. By a comma, that is this. comma, and for the create table command, this list is enclosed in parentheses. So this is the parenthesis here, enclosed in the bracket. Data types, character, variable, character, boolean, integer, real, date, time. Those things are there. So create table we did. Just now we did practically and so on. In task 11.03 for the database defined in worked example 11.02, complete the DDL for creating the 4 tables. So 11.03 is important. You can write it first, then try it on this, the link that I have given. You can try out on your own and see the results and check out. Use variable character 8 for booking ID. So the instructions are given here. You can make use of these and try out that task. Now we come to data manipulation language, DML, where we change the data. The insertion of data into tables when the database is created. That is one. After creating the database using DDL. Now, if you want to insert data, you have to use DML, or to modify or remove data in the database, or the reading of data also is called DML. Reading also you have to use data manipulation language. We don't change, but even to read regarding data. Populating a table with data. This is the way. Insert into band computer kit. So let's do this. Copy this. Practically, we'll see. Insert into band 3. We have to change this. We are referring to something that we created now. Band name. Is it correct? What did we do earlier? Band name and numbers. Or if you enter here, you can see the field names. If you click here, no, it won't view. Yeah, we have no records here. 0. The number of records is 0. So let's see whether it's the same. Band name, number of members, and also agent. Band name, number of members. Yes, that is correct. Additionally, we don't need, it's not essential, but band 3, band name, number of members, comma, agent, and the values. This is the way. First you give the field names, right? First you give the field names in inverted commas here between single inverted commas or double. Then you give the values. Why is this? Because of this. Picture. Okay, we'll forget about that. We can insert only 2 values, A, B, C, and 3. ABC is the band name. We'll take the my band. Or you can even have two words like my band, because the band name, and members, make it 7. And run the SQL. Now you can see one record added here. Can you see? It didn't show earlier. If you click here, you get the details here. Otherwise, we'll use the We'll copy this first so that you can add another record. Yeah, we'll add another record straight away. My band, which is your band. Your band and members 5. Run SQL and you can see 2 here. Now do a select all from band 3 semicolon. There you are. You can see my band with the band name, number of members 7, and your band 5. These are null because we didn't enter anything here. There was some problem there. Usually you get problems with this kind of thing, different versions of SQL also. It's not the same everywhere. Now, if you want only the band name, what happens? Instead of this, you type band name from band 3 on SQL. Now see, only the band name comes. Because there's no asterisk here to say all. Instead of that, you give this thing. And also band name and the other number of members. Without the agent coming here. There. Now the agent is not coming here because we are selectively taking there. So it's really interesting. You must try to do this. Yeah, there are some more. This is one that we did with a little bit of addition. Don't worry about this because this I put it as okay. If not for this website, I have to go into my own website and show my database there. So no need now. The query always starts with the select command. Query always select. We saw no, we select all or select field name. So select band name from band. That's what we did just now. The band table only has 2 attributes. To list the values for both, there are 2 options. Either select band name, number of members from band, or select asterisk, that is all from band, because there are only 2. So whether you write like this or this is the same result. This is short. Asterisk equals all attributes, all fields. Then to sort output in band name order. Select band name, number of members from band. Up to that, nothing new. We already know about this. New is this, order by band name. So it will be alphabetically sorted and output. To prevent duplicate entries, group by, same thing, the same thing, group by band name. So that there are duplicate. If it's a booking, there are many bookings under one. That will come only one, like a summary. Then there are aggregate functions. There are things called aggregate function. Select count. Like in spreadsheets, you get count, you get sum. So count means it will display the number of members in a band. So from this band, how many members altogether, all the bands. Sum, it will add up. This will count the number of records. This will count the number of records where the band is there. Now here this will add up sum. Sum is to add all the number of members. Join condition between data in 2 tables. Yeah, so that is also another way. Join. That's a little bit advanced. Join here, there's an explanation here. So select all from booking where band booking dot booking ID. This is called the dot notation. Table name and attribute name separated by a dot. So here band booking, the booking ID can be somewhere else also here. Yeah, booking ID can be in the booking table as well as band booking table. So to identify which one, you write the table name first, then dot and booking ID. Where? So select all from booking, where band booking ID equals booking ID. So where it is matching all the bookings which are for this booking ID. And so you can combine also here. Combine the conditions just like in the normal logic. And band booking dot band name equals computer kids. So interrelated like table name and attribute name separated by a dot. Some versions of SQL require the explicit use of inner join. So you don't have to worry. The following is a possible generic syntax. You don't have to worry about that. But some versions you will find if you do any research on the internet, if you find something like this, then not to worry. That is the peculiarity with some things. But here is an example anyway. Select table 1 dot column 1, table 1 column 1, then table 2 column 2, and so on. From table 1, from this table, inner join table 2, inner join table 2 on table 1 dot common field. There should be a common field for that. There should be a common field for this inner join equals table 2 common field. So something like this. Something like this, but explicitly you have to say inner join. If the band computer kids recruited an extra member, the following SQL would make the change needed. One, update. So this is a DML again, no? Because sorry, DDL. It's not. Oh, I'm sorry. This is DML. Yes. Update band set number of members equals 6. So you are changing because in the computer kids, where band name equals computer kids. Computer kids, there's a new member joining. So you have to change it. So this is the way. Set number of members equals 6. And the command is update. If the ITV's band decides to disband means to stop. After that, no performances. So delete is the term from band booking where band name equals ITVs, or delete from band where band name equals ITVs. Not all, both, no? Because the band booking and band, two places, but in both places you have this. So you have to delete from both. Then here are some of the most important SQL commands given here. Here is another one. In detail, the SQL is given in detail. Data definition language, the DDL, DML, SQL structured language, basic commands, select. Lot of details given for extra reference. This also will be there in your course page. It is very important that you do practically or you memorize it. You have to memorize. But doing practically is the best way. Some extra things are also there. So extra knowledge, right? All right, then. So that is the end of database chapter 11. So I hope you will do all the practicals, the tasks and everything and improve your knowledge. See you in the next video. Bye.